Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is the last part on internal forces and moments, and this is about shear and moment in beams, the construction by the area method. Although there is one particular problem here, especially the first one, where we don't need to draw shear and moment diagram. We'll just determine the shear and the moment in a particular section. And I hope that you can follow by also studying the previous examples as well as the distributed forces, which are your foundation in the analysis and understanding of this part. Level 51, derive expressions for the shear force V and the bending moment M as functions of X in the cantilever beams loaded as shown. So here's the beam loaded with composite loadings. We have rectangular, we'll divide this into rectangular, and a second degree intensity of loading given by W equals WO plus KX square. So we will divide the loadings into rectangular and spandrel of parabola loading. So we'll call the reaction shears as AY, then AX is 0, moment at A, let's assume positive, so clockwise. And let's divide the loading into rectangle. So this is 100 times 10, so P1, 1000. And this one is 1/3, because that's second degree, 1/3 of 10 times 400 minus 100, so this is 300 for the parabolic loading. So this distance is 5 feet. This distance from the vertical leg is 1/4 of 10, so 2.5. So from the left, from A, 10 minus 2.5 is 7.5 as shown. So P1 is 100 times 10, so it is 1,000 pounds downward. P sub 2 is 1/3 of 10 times 300. Take note, this is just 300, 400 minus 100. So it is also 1,000 pounds. So that AY is AY, summation versus Y, AY minus P1 minus P2 equals 0. So AY minus 1,000 minus 1,000 equals 0. So AY is 2,000 pounds. And summation moment AMA plus 1,000 times 5 plus 1,000 times 7.5 equals 0. So MA is equal to negative 12,500 pound-foot. So we retain the direction, but its sign is negative. So therefore, at any section X from the left, so this is the FBD, and intensity of the loading is W, general. So again, we divide the loading into two parts, rectangular and this parabolic part or spandrel of parabola. So this is W minus 100, and this is X. So we have positive shear, reaction 2000, then moment clockwise negative 12,500. No AX, positive shear is downward. So this is 100X, and this is 1/3 of X times W minus 100. So that distance is X over 2, while this distance of this force is X over 4. So this is the positive shear, positive moment. So shear is 2000 minus 100x minus x over 3 times W minus 100. So let's compute this W minus 100 by squared property of parabola. W minus 100 as to square of x equals, take note, this is 300 as to 10 square. By squared property of parabola, W minus 100 as to x square equals 300 as to 10 square. Therefore, W is equal to 3x squared plus 100. So comparing with this given equation, we conclude that WO is 100 and K is 3. Therefore, the W minus 100 is just 3x squared, or W is simply 3x squared. So shear therefore is 2000 minus 100x minus x over 3 times W is 3x squared plus 100 minus 100. So cancel. So this is just the W. So therefore the shear equation in this section is 2000 minus 100x minus x cubed, and that is in pounds. Then for moment equals 2000 times x plus negative 12,500 minus 100x times x over 2 minus x over 3 times 3x squared times x over 4. X over 3 times 3x squared, because W minus 100 is just this one, 3x squared, and the moment arm is x over 4. Simplifying, moment is 2000x minus 12,500 minus 50x squared minus x to the 4th over 4. So moment equation rearranging is negative 12,500 plus 2000x minus 50x squared minus 1/4 of x to the 4th. So that's it for this level 51 problem. Level 52. Draw the shear and bending moment diagram for the beam by the area method and determine the maximum absolute values of the shear and bending moment. So here's the figure. Let's denote the tension in cable CD as T, and let's solve for the angles. So the angle is arctan of 14 only, not 18. 18 minus 4 is 14 vertical, then 20 horizontal. Arctan of 14 over 20 is 34.992 degrees. So therefore this is T cosine 34.992, the horizontal component, the vertical component T sine 34.992 degrees. Then at H we have Hx and Hy. Summation of moments about H equals 0. So we have clockwise positive T sine 34.992 degrees times 20 minus T cosine of 34.992 degrees times 4, then plus 50 times 6, then minus 100 times 10 minus 50 times 26 equals 0. From there we can solve for T. So using your calculator, T is 244.1 pounds. Then 244.1 pounds sine of 34.992, we convert that into the figure shown. 244.1 sine of 34.992 degrees is 140 pounds. Then this force is 244.1 cosine 34.992, it's 200 pounds. Since it acts at E, then we transmit it at D rather, we transmit it to E. So these are the components of the force of tension. Then also this 200 pounds will have clockwise moment about E, which is 200 times 4, so 800 pound-inch. Then at H, summation forces Y equals 0, so Hy plus 140 minus 50 minus 100 minus 50 equals 0. So Hy is equal to 60 pounds. Then Hx must be equal to 200 pounds also, but it is leftward. Summation forces X. So let's transmit these components. So we have 60 pounds, then 200 pounds to the left. Then the moment due to Hx about G, we transmit it to G, is 8x counterclockwise. 8x 200 times 8, so 1,600 pound-inch counterclockwise as shown. So we are now ready to plot the shear and moment diagrams. So this is the shear diagram. So first we go down by 50, so we have negative 50 here. Then between A and E, there's no change in, there's no loading, so it's just horizontal, constant. Then plus 140, so 90. Between E and F, no change in loading vertically, so constant. Then minus 100, negative 10. Then constant, plus 60, so 50. Then constant, then minus 50, so that closes. So that's the shear diagram. Let's shade it. Then for the moment diagram in pound inch, so beginning with A, which is 0, then we have a negative constant shear ordinate, so constant slope negative. The area is negative 50 times 6, so negative 300, straight line here, negative 300. Then since there is a clockwise moment which is positive, so negative 300 plus 800, so 500, it changes abruptly to 500. Then 500 plus the area here, which is 90 times 10, 900, so it is positive 90 slope line. 500 plus 900 is 1400 here. Then minus this area, which is straight line going down. The area is 10 times negative 10, so 100, so 1300. Then there is a negative counterclockwise moment, so 1300 minus 1600 is negative 300 here. And finally, plus the area of this shear diagram, 50 times 6, 300, and it is a line with constant positive slope of 50. Then 0 here. So that's it. This is the moment diagram. Let's shade it. And let's answer the absolute maximum value of the shear. From the figure, it's 90 pounds. And the absolute maximum moment is 1,400 pound-inch. So that's it for this problem. Level 53, the beam AB is subjected to the uniformly distributed load shown and to two unknown forces P and Q. Knowing that it has been experimentally determined that the bending moment is positive 800 Newton meter at D and positive 1300 Newton meter at E, determine P and Q, then draw the shear and bending moment diagrams for the beam. So here is the figure. Take note that the loading is 20 kilonewton per meter and the given moments are in Newton meter. So a reminder that we should be consistent with our unit. So let's call the reaction at C, the vertical as Cy, and Cx is 0, at B, R sub B. Summation moment about B equals 0. So we have Cy times 0.9 minus Q times 0.3 minus P times 0.6 minus 20 times 0.3 times 1.05 meter equals 0. So 0.9 plus 0.15, 1.05. Simplifying, Cy equals 2P over 3 plus Q over 3 plus 7. Likewise, summation moment about C equals 0, R sub B times 0.9 plus 20 times 0.3 times 0.15 minus Q times 0.6 minus P times 0.3 equals 0. Simplifying, R sub B is equal to P over 3 plus 2/3 of Q minus 1. Then for the free body diagram, so that we can determine the moments, let's prepare the shear and moment diagram. So this is Cy 2/3 P plus 1/3 of Q plus 7, and R sub B is 1/3 of P plus 2/3 of Q minus 1. And this is the free body diagram up to D. The positive moment is counterclockwise and it has a value of 0.8 kilonewton meter. So summation moment about this section equals 0, so MD equals quantity. This is also the free body diagram for portion AB. So let's just consider section A to the right, not section A and to the left. Much simpler if we consider forces A and to the right. So positive moment is clockwise as shown. So MD is equal to 2P over 3 plus Q over 3 plus 7 times 0.3 minus 20 times 0.3 times 0.45. Simplifying this equation, and moment about D is 0.8 given. So we have the first equation, 0.2P plus 0.1Q equals 1.4. Call that equation 1. Then ME is simply P over 3 plus 2Q over 3 minus 1 times 0.3. So ME equals P over 3, which is 1.3 kilonewton meter, P over 3 plus 2Q over 3 minus 1 times 0.3. Simplifying, so we have 0.1 P plus 0.2 Q equals 1.6. Equation 2. Solving equations 1 and 2 simultaneously, we get P equals 4 kilonewtons and Q equals 6 kilonewtons. Then for the values, we have P 4 kilonewtons, Q 6 kilonewtons, Cy is 35 over 3, and RB is 13 over 3. So we are now ready for the construction of shear moment diagrams. So beginning at A, the shear is 0. Then we have loading area negative 20 times 0.3, so negative 6. Sloping down, constant slope. Constant slope of negative 20, but it is a straight line. Then we have negative 6 here. Then plus 35 over 3 going up. So it is 17 over 3, or in decimal 5.667. Then constant shear in this part. Then minus 4. So we have 5/3 or 1.667 constant between D and E. Then minus 6. We have negative 13 over 3 or negative 4.333. Then constant. Then it closes because of the reaction 13 over 3. So that's the shear diagram. Let's shade it. Then for the moment diagram, beginning with A, which is 0, then this is 0 slope to negative 6 slope, so concave down. The area is 1/2 of 0.3 times negative 6, so it is equal to negative 0.9. Then plus this area here, which is constant slope, constant shear ordinate, so it's just line, plus 17 over 3 times 0.3, negative 0.9 plus 17 over 3 times 0.3, and that is equal to 0.8. Then plus 5/3, so that's why it's 0.8 moment at D, plus 5/3 times 0.3, 0.8 plus 5/3 times 0.3, another straight line but with lesser slope, is 1.3, which is given here, moment at D. Then minus 13 over 3 times 0.3, and that should be 0. So sloping towards 0 here, straight line. So that's the moment diagram, and it checks with the given moments at D 0.8 and at E 1.3. So that's it for this problem. Level 54. Draw the shear and moment diagrams for the beam loaded as shown and specify the shear and moment M at the mid-length of the beam. So here is the given figure. We have parabolic and a rectangular or uniform load combination. The positive x direction is to the left. Take note. So this is the free body diagram. Let's have the shear in general. This is x and moment is positive clockwise. We divide the loading into rectangular and spandrel of parabola, and also the entire loading. So therefore this is 900 minus 500, so that's 400 Newton per meter. and that is x. Therefore, this is also x, positive direction. So this is w minus 500. So w minus 500 as to x square equals 400 as to 6 square. So w is 500 plus 100 x square over 9. So that means WO is 500 Newton per meter and K is 100 over 9. So this is 100 x square over 9. This exists here. So that this is 100x, sorry, 500 times x. The moment arm is x over 2. And the other one is 1/3 of x times 100x square over 9. 1/3 of x times 100x square over 9. And its moment arm from the left is x over 4. So simplifying, that's 100x cubed over 27, and its distance from the left is x over 4. So shear equation, summation versus y, shear is equal to 100, shear minus 500x minus 100x cubed over 27 equals 0. So the shear equation is 500x plus 100x cubed over 27. Likewise for the moment, so at x equals 3, we substitute x is 3 here. The value of the shear at mid-length of the beam is equal to 1,600 newtons. So that's the answer to this question. Specify the shear and moment at the mid-length of the beam. So that's the shear only. Now for the moment, summation moment about this section equals 0. So that's x over 4 moment plus 500x times x over 2 plus 100x cubed over 27 times x over 4 equals 0. So moment is negative 250 x squared, then negative 25 over 27 x to the 4th. At x equals 3, we substitute x is 3 here. So it is negative 250 times 3 squared minus 25 over 27 times 3 to the 4th. And the moment at mid-length of the beam is equal to negative 2325 Newton meter. Then for the shear and moment diagrams, so AY is equal to the shear when x is 6. We substitute it here when x is 6 because the origin is here, going to that direction. So AY is equal to 3,800 newtons, while the moment at A is substitute here, x is 6, negative 250 times 6 square minus 25 over 27 times 6 to the 4th, and it is equal to negative 10,200 Newton meter. So we are now ready to sketch the shear and moment diagram. So this is the moment, and that's the shear. So beginning with shear 0, then 3,800, then we have a loading which is negative and decreasing. Negative decreasing is like that, as shown. So that's the shear diagram. For the moment diagram, by the way, the value of the shear in general is given by this 500x plus 100x cubed over 27. For the moment diagram, beginning with negative 10,200 here, and since this is positive, so positive decreasing, so it looks like that. And the moment is given by negative 250 x squared minus 25 over 27 x to the 4th. So that's it for this problem. Level 55, this is the last problem. Draw the shear and moment diagrams for the beam loaded as shown. Specify the maximum moment. So there's no x-axis, so I'll select the origin as the center of the beam as shown, and we'll consider only the right half, and the left half must be established. The equations will be established based on symmetry. So AY equals RB equals 1/2 of L over 2 times WO because of the symmetrical loadings. So AY equals RB equals WO L over 4. So this is 1/2 of L over 2 times WO. So WO L over 4, same is true with the right side. So this is now the free body diagram. So positive shear is upward, but it is 0 because WOL over 4 minus WOL over 4 is 0 already at the midspan. And the moment is maximum at the midspan. Then that's the origin. This is W. This distance is X. And based on area, this is 1/2 of X times W. So 1/2 WX for the entire loading, WOL over 4. And RB is WOL over 4 also. This distance is 1/2 of L over 2, so L over 3. So that's WL over 4. Max plus WOL over 4 times L over 3. Then minus WOL over 4 times L over 2 equals 0. So Max is equal to WOL square over 24. So that's the maximum moment. Then at this section here, W as to X equals WO as to L over 2. So W is 2WOX over L. So the shear equation here is 0 minus 1/2 of WX, and that's the positive moment. So shear is 0 minus 1/2 of WX, and W is 2WOX over L. So the shear equation is negative WOX squared over L. Likewise, for moment, it is W max WOL squared over 4 minus 1/2 of WX times X over 3. This is X over 3, moment arm of this imaginary loading. Simplifying, substitute the value of WO. So WOL squared over 24 minus 2WOX over L, which is WX squared over 6. So simplifying, moment is WOL squared over 24 minus WOX cubed over 3L. So that's the moment equation. We are now ready to plot the shear and moment diagrams. So for the shear, beginning here, it's 0. Then minus WOL over 4, negative increasing, so it looks like that. So WOL over 4, negative decreasing, 0 slope here, so that's why the curve looks like that. And here, 0 slope to negative slope, so concave down. And that's the shear diagram. For the moment in Newton meter, so this is positive decreasing, maximum at the center. And the maximum moment is already computed, WOL squared over 24 as shown, so that's the moment diagram. So the equation for shear here, right and left, this is the positive x direction, positive x direction. For moment, WL squared over 24 minus WOX cubed over 3L, and for this part, that's the equation. So that's it for this problem.